Let's start with OP, Object-Oriented Programming in 7 minutes by Marshall pronunciation. So let's go.
Yeah, I watched this video and I see this video has two errors to
Mhm.
describing object-oriented programming. Yeah, object-oriented programming has four pillars: encapsulation, abstractions, polymorphism, and inheritance. Uh, And after procedural programming, object-oriented programming is launched because procedural has reduced the code with just a function, but you have a redundant code and create a spaghetti code in the uh, one file in the procedural paradigm. So, object-oriented programming is or OOP. The encaps you work with the objects, and everything is as an object in the
Mhm.
object-oriented. So you need to create a blueprint as a class, and in the blueprint you have a property and method, and you create object from the class. You create instance of object from the class that support your the properties and behaviors. The first pillars in the object-oriented programming is encapsulation, but the video talk about encapsulation just is a bunch of property and method. But I think encapsulation is related to capsulate data, and
Mhm.
you try to protect data from the object, and the other outside of the object cannot access the protected data.
Yeah.
And after that, we have abstraction. And again, he talked about abstractions, just hidden implementation. But he talked about you can working with a private method, private data. But I think abstraction just hidden implementation, and you have an interface from the code, and other client or other people can access from the interface, and we don't know about the implementation of the code. And but the talking about abstraction and encapsulation, I think the video is wrong.
Mhm.
And after that, we have inheritance. Inheritance is help us to reduce redundant code. When we have a common a method, common property in two class, we create an inheritance class that move on the common to the top class, and this child class is related to the top class, and help us to working with one class to, for example, when we need to changing a method, we just changing a one class, one method in the one class, and we need to duplicate to both classes. And the final pillars in the object-oriented programming is encapsulation. Sorry, polymorphism
Yeah.
is the name is many forms. You can work with the, for example, the polymorphism is related to the overrided and overloaded.
Mhm.
And
Yeah.
in overloaded method, you create a method with the same signature but with a different parameters, and is a name is compile time polymorphism. Overrided means you have a different implementation in the subclass,
Yes.
and the name is runtime polymorphism. and help us to, for example, when we have a lot of switch case and if and else, you just want calling a one method from the parent, and it depends of the instances of which classes the action that related with child class, and that's it.
So we let's talk about the pillars. I mean, the encapsulation and abstraction there. I mean, really common. He didn't talk about the attributes and the access modifiers. We go to more depth and talk about encapsulation. I mean, what's the primary reason for encapsulation? If we don't have it, what happens?
Yeah, and the primary reason I think, I remember in the interview they asked me how to prevent the other developer don't access to the property in the
Mm-hmm.
other
Okay.
classes, and I don't know about the meaning of prevent in the
Yeah,
interview.
I can remember that.
Uh, Yeah, the encapsulation that help us to prevent some properties or some methods that I don't like accessed from outside of the objects, and other developers cannot access to the method or property the outside of the in the objects that help us to preventing
Yeah,
this.
actually, it's like
Um,
protection while we have a gateway. If we want to do something in that property, we have to ask. So there's a getter or setter. This encapsulation is for privacy concern that we have. So accessing those data, method, and variables or function that we have.
yeah.
Uh,
Uh,
yeah,
your video is
blurred. I'm not sure, but I mean, this problem
blur.
is the camera, really. Yeah, I think it is okay
Yeah,
right now. Yeah,
no, it's okay now.
yeah. So the encapsulation, let me sign. Talk about the functions later. And abstraction, the impact of change. I mean, the use case of abstraction is to reduce the impact of change, which means, can you tell me about that? What's the reason that, for example, abstraction helps us to reduce, I mean, changing in the code? What does that mean?
Yeah, for example, when designing a REST APIs, we first create an interface of the REST APIs and send to other clients that use it. But when we need to changing the implementation, just changing the implementation, and we don't changing the interface. And other people cannot see the changing in the interface. For example, just work it the REST APIs in the post APIs, but the implementation and business we change it
Yeah,
without
that's the reason that for
effective to the.
solid in solid principle, Robert C. Martin says, rely on abstraction, not concrete implementation. This abstraction somehow abstracts away the implementation from the accessing or APIs to our code. So while we can modify the implementation, we have the API layer between the application and outsiders remains the same. We do not touch it with abstraction. So that's the whole purpose, the meaning of abstraction. Let's talk about inheritance that many people critics about OOP. I mean, nowadays people say composition is better, inheritance is kind of dirty, not reliable or testable. What do you think about this?
Yeah, for example, when you're using composition, you can mark the dependency of the class, but in the inheritance, you cannot marking the inherit
Mm-hmm.
classes because just working with the parent, and you cannot marking them to the child. And
Which one do you prefer? Do
and
you prefer composition or inheritance? Or there are some principles that in which condition we should, for example, any of composition or the inheritance. Do you have any rule of thumb or no? I mean, depends really. Just
I think it depends of the logics. For example, uh, yeah, when we needs to, for example, create a util class and help us to the utility of the class and using a composition. But when we have, as for example, this same saving method in the both of class, inheritance is better because just one save and using the two child. Um, and I think it depends of the business.
So polymorphism was clearly said. I mean, also talking about the overloading and overriding the differences. Let's talk about your experience. I mean, most of your experiences with OOP. I mean, how much you're satisfied with this, I mean, style of programming? Do you think it's enough? Do you think that we need a new paradigm or no? Still, there's space to learn OOP and we can go, I mean, dig more and knowing the OOP much more in depth.
Yeah, I understand your question about the just four pillars is enough, and we need to or not, or the
Yes,
question is
somehow. My
related.
question is, does OOP or is OOP able to solve all the problem that we have in coding? Or no, you think, for example, we
Mhm.
have to combine OOP with functional programming and some procedural. I mean, what do you mean? Because most programming language are multi-paradigms. They have like 70%, I don't know, OOP, 20% functional programming paradigm, and 10% procedural. I mean, what do you think? In your experience, have you be able to code everything in OOP, pure OOP? For example, Ruby is
Yeah.
considered the very clean design for OOP, other than Java and Ruby, and they think they can solve everything in OOP. What's your experience tells? What your experience tells about that?
Yeah. Yeah. I work with Java, and Java has functional, OP, and procedural, I think, and other paradigms such as AOP and reactive programming.
Hmm.
Uh, Yeah, I think that combine all of them is better because sometimes we need to do functional programming when we work with a list of data and we need to manipulate the data during the list and changing and returning the other data of the list. We using functional programming is better than object-oriented programming because I think the line of code is reduced and we don't need to work with the sum of the method in the list and just writing a three line of codes that return, for example, we mapping a data in the list to other lists with writing a three line of codes and return the data. But in the object-oriented programming, we need to, for example, create another class that help us to mapping the list to another list and create a for loops and other sides. Uh, but I think combine all of them is better than
So
pure
can
object
you tell me
oriented,
about
the
the
pure
pros and cons of
function.
OOP? I mean, what do you like about? What do you dislike?
Yeah, I like OOP because you can model the real life as an object. Real, for example, you can model car as an object or business as an object to the code and help us to, for example, create a classes and using some patterns to solving some problems in the OOP and reducing the duplicate code by using a OOP and patterns and that's it.
No. The question was about pros and cons of OOP. What you said is also applicable to functional programming, specifically pros and cons of OOP. So if it was an
Mm.
interview, you would be
Pro-
rejected really for this question.
Pros and cons.
Pros and cons
The
of
pros, I
OOP.
think, yeah, the pros of OOP, I think, reducing code.
Encapsulation, Abstraction,
encapsulation,
polymorphism, these are
abstraction
the
of
main
the
core pros of the anything else you want to add?
and yeah, reducing code and uh,
Code usability. Reducing code doesn't make sense.
button
Code
con
reusability,
code usability,
which also true in functional programming. If we
code usability.
define each function pure and small, we have code reusability as well.
Mm.
What about cons? What about problem in OOP? We talked about it last session, I think.
Testability, I think
Yeah.
testability is
Testability.
hard, but yeah,
It doesn't mean it's
in
not testable. It means it's harder to test comparing to functional programming.
yeah, exactly. But another cons of OOP, uh,
If someone doesn't have enough experience, it easily gets messy. I mean, the code in large code, it becomes messy. In functional programming, we have to design the code in order to make it work. The very first one is thinking about the functions and data flow, and then designing the function and working with the function. When it was working or when it gets to work, it's okay. In OOP, we can, I don't know, create many classes, many routines, many, I don't know. But when it is complex, it's hard to manage the state or find the state. Debugging is harder. It becomes much more complex and messy. I mean, most spaghetti codes are OOP, not functional programming. Because functional programming, you have to first think about the data and data flow. In OOP, you do not have to think about data flow. You can just code. Later fix it. And when it becomes a bigger one, for example, we have God class. If you know about the God class, that's the reason we put everything in that class. But we don't have, or I never heard about a God function in functional programming because we keep it small at the very beginning. We do not update it, we do not touch it. In OOP, we make a class, we keep adding to that. And then after 2 years, we have a God class that controls any other classes. So in large application, enterprise application, if we aren't careful, somehow we make lots of God classes and then messy code. That's the cons with, at least in my experience that they have did like 6 months in code with OOP. And probably you should know more because you have more experience with OOP. Please read more about its pros and cons, exactly about OOP, not about the general programming. Tell me about challenges you
because
faced. Yeah,
because I focus on solid and I try to don't create a God class.
yeah. Can you tell me
And
about
when we
challenges?
use a single responsibility,
Can you tell me about the challenges you faced with OOP?
the challenges I faced.
I mean, you
Uh,
use OOP and you thought, okay, this paradigm is hard to solve this problem. A kind of challenge. It was hard for you to implement or reason about an OOP.
Let me think about it. Uh, yeah, I didn't remember any challenges that I have in the OOP
Yeah, you could solve
because I think
anything that
it's
any
not.
task that assign you could solve.
Yeah, that I think that the task is very related to the object-oriented programming, and I can solve it. But I have challenges with Java. For example, I need to create APIs that create a PDF in Java, but it's hard. But when I write a Python code, that is easy.
Okay,
Creating a
you mean
PDF
the
from the
problem
Python
is
code.
not OOP. The problem is implementation of OOP in different programming language. Okay, that was the challenge you faced. Let's go to some interview question. How does Java support multiple inheritance using interfaces?
Yeah. Java use interface to multiple inheritance, And before Java 8, we have just create a abstract, full abstract method in the interface. But after Java 8, we can create a default method with implementation. And Java that protected from the diamond problem in the inheritance. So you cannot extend multiple classes, and you can extend multiple in interfaces. The diamond problem has two issues. First, this subclass cannot know the same property in the parent and subclass and child cannot know this property is about parent or is about yours. And the Java doesn't support this because you cannot inherit multiple classes. But after Java 8, the Java supports default method in the interfaces, and you can create a method with implementation. Again, we have another issues when we have two method in child and interface with the same name, and in the interface is a default method with the implementation, and in the child has an implementation. So in Java, we need to implement the method and overriding the method as a default method in the child class, and just using an override. And that's it.
So let's talk about the tell me shortly the solid principles and give me real world examples if you have implemented.
Solid principles. Yeah, in the solid principles, the S is single responsibility, and the real example about single responsibility, I think, microservices is a single responsible as a service,
Hmm.
and in architecture, for example, clean architecture use cases is a single responsible because you can create like for example, getting users, getting user use case, just get users and don't have any other implementation of the business of the users. And open close principle, you open for extension, close for modification, and similar the creating interfaces and and interfaces implement from the other classes, and you can just extend the other classes. For example, the one class they implement the own, and the other classes implement the other size, and we don't need to modification of the method. For example, just one class as a one method, and we modify for supporting both logics, and we can extending both logics to as a separated class. This the third one is list of substitution.
Yeah.
uh, yeah, that means you can working with a parent and child, and it is interchangeable. For example, when working with a child, instead of when working a parent instead of child in the other side of the code, the changing between parent and child without affecting of the code, because both of them has a same method, and you call the method is similar a polymorphism.
Hmm.
And uh,
Interface
the
segregation.
fourth interface segregation is you just one interface with many abstract method is not good because you can other child of other classes is implemented the interface needs to implement all of them without needs, so you can separate the interface to the separated of interface and the class when needs to the implementation just implement the interface. And the last one is dependency inversion. Is means when the classes depend on the other classes, just using an abstract of the abstract module of the class, and we don't managing to, for example, create instances of the class because just working with uh, abstract of class and using a constructor to inject the object to the class because that help us to uh, creating easy testing for this class, and we can when we using this class you can support other type of objects to the class with the implementation, and that's it.
So how can we reuse code in OOP without decoupling, without coupling actually classes?
um,
Actually, how to decouple
um,
classes while reuse the classes? Code reusability without coupling.
mm,
What's the pattern?
Good reusability without coupling. Can you explain more
Yeah, we talked
and
about
give
it.
an example?
Reusability in OOP is possible in two ways. Is a class
Yeah,
inheritance has a composition.
is a composition.
Inheritance couples the classes, links together.
Yeah,
Composition, no.
no, loose coupling.
So which one couples them? Inheritance. Which one
Uh,
decouples them?
Inheritance,
Composition.
composition.
Composition is for
Yeah,
decoupling. Yeah, the question
yeah.
was which reusability pattern or method we can use in order to avoid coupling. Answer is
Use, using composition.
using composition. It was a tricky question actually. So actually we have time and also we continue with OOP. I mean for next session there's no need to watch a video. We continue with OOP. I want to ask more about OOP unless you don't want. So if you think it's enough, we go to next subject. Otherwise we continue with OOP because I want to ask more complicated questions in OOP.
Okay.
Um, so can you tell me about the consequences of violating encapsulation in large Java code? Let me read the question. What are the
Mm,
consequences of violating encapsulation, which means do not properly encapsulate the classes that we have in large scale Java system?
yeah, I think the other client can use access the property of a method of the
Yes,
class
which causes,
easily,
which
and
causes,
for example, yeah, for example, we need to create a setter for this for the some properties, and in the setter we need to checking, for example, the value is greater than some things, and checking a condition and return an exception. But when the other clients access the directly the property that can setting the value directly without checking the business rules.
yeah, when we do not have a kind of uh, well designed privacy or encapsulation, most classes can reach out, can check other classes. When we read, for example, some values and function call, it increases coupling. So coupling is increased when we validate the encapsulation we do not implement it properly. The other one is hardening to refactor or
Yeah.
following single responsibility principle when there are many classes accessing other classes. Another thing is side effect. You have more side effect and debugging and testability of the application decreases. And also, I mean, the modularity of the code that we have decreases because the integrity between codes is huge. I mean, the code are dependent on each other, the classes are dependent on each other. So weak modularity, unpredictable behavior, harder to refactor, and increase coupling when we violate the encapsulation in OOP. Oh, any other question you have?
No question.
Yeah,
Thank you.
please. So, do you want to continue with OOP or no? You want to change the subject
We can change the subject.
for next week?
Yeah.
Okay, I will give you access to other topics. Any question?
No question. Thank you. The
Have a good
next
time.
week, we are started at 9:30.
9:30 next week. Yeah, I have a new student and he's not able to join at 9:30. So you go to 9:30 and you start 9 till 9:30. Any question?
Okay. No question. Thank you.
Have a great time and weekend and bye for now.
Bye.